So with that, I'd like to introduce Vijay Kumar. And when I Googled Vijay, I found his wiki site and Wikipedia site, and it called him a roboticist. I think that's really cool. He's our dean. He was elected to the National Academy of Engineering in 2013. He's an outstanding teacher. He's been director of our GRASP lab. And most importantly, go to this TED Talk. It is the coolest TED Talk I've ever seen. It's about robots that fly and cooperate. And if you get anywhere close to the number of hits that website has, I think you've been pretty successful. So with that, Vijay has a few remarks for us.
Thank you very much, Russ. Although I really have to work on my acronyms here. I don't have a single acronym on this page. Good afternoon and welcome, everyone. And on behalf of all of us at Penn, I want to extend a special welcome to especially the participants from overseas, Xavier Maurice and Sarah Monde, the director and associate director for CNRS for North America, Hervé Martin from the attaché of science and technology in the Embassy of France, of course, all the participants from Bryn Mawr, Villanova, and Alabama State University. Thank you for being our partners. And the visitors from GIANT, that's another cool acronym, the Grenoble Innovation for Advanced New Technologies. And I'm just amazed that there are 37 participants and 80 trainees in this project. What a cool project. Let me first start by congratulating you on actually getting this grant. I know what the competition is like at NSF, and to be one of 17 awardees for PIRE, which is one of the most competitive programs, especially in such a hot area, I think that really deserves a round of applause. So congratulations. At Penn, I think there's a lot of support for the sentiments in underlying REACT. At Penn, we have a vision for expansion of the university, which President Gutmann calls the Penn Compact 2020. In this compact, there are 3 I words that characterize the compact. So the first I word, those of you from Penn know this, but the outsiders don't, so I'm going to tell you this. The first I word is about integrating knowledge. The second I word is about innovation. And the third I word is about impact. So if I look at your project, the vision to create tailored coatings with customized chemistry, texture, and function using polymers and embedded nanoparticles, if that is not about integrating knowledge, I don't know what is. It integrates science with engineering, basic research with applications, and research and applications. So that's your first I word. The second I word is obviously innovative. The use of active coating technologies to transform passive surfaces into functional devices, that is truly an innovative concept. Third, and I think this is the most important to me, that these active coatings actually address societal needs. They impact humanity on a global scale, potentially providing access to clean water, prevention of the spread of disease, the creation and storage of clean energy. That is impact for you. I want to come back to innovation, though. We often use the word innovative quite loosely. In the US, we adopt a very US-centric view, and we claim that all innovation happens in Silicon Valley. I'm sure those of us in Philadelphia don't agree with that. But in the Silicon Valley, if you go and ask what innovation is, and I'm going to recall a quote from Peter Thiel, a Silicon Valley venture capitalist and entrepreneur, actually quite a controversial guy, a libertarian. But I like this quote. He had this following observation about innovation in the Silicon Valley. He said, "We asked for flying cars, and all we got was 140 characters." So the 140 characters is obviously a reference to Twitter, and flying cars is a reference to a big challenge, a challenge to all the entrepreneurs, to all the venture capitalists to actually solve big problems. His main point is he wanted to see game-changing innovation coming out of the Valley, and he was disappointed, and rightly so. Because even though we've had new technologies like Twitter, arguably the talent that's there in the Valley could have had a lot more impact in the world if it had been channeled correctly. So to me, this project, REACT, is a flying car. Although it doesn't look like a car, it doesn't even have the cool logos like a flying car might have, or the logos don't connect to a flying car. These are not about low-hanging fruits. These are about big challenges. And that's why I think it's innovation. It's when I saw this project, I was reminded of this exercise that we've been going through over the last 6 months in the school as we think about our strategic plan for the next few years, about what areas to expand in, what new programs to create, how to educate our students. And we asked ourselves the same questions that you probably did. What are the big challenges, grand challenges facing society? And we came up with 5 themes. The first being engineering human health to fight diseases, to fight pandemics, and to improve the quality of life. The second, data science and computation, thinking about technologies that could change the traditional way we combine modeling tools, simulation tools, and experimental tools in research and discovery. Third, sustainable energy, to ensure that our species survives in the next 30 years. Nanoscale devices, manufacturing, which is the solution to many of the problems that we face today. And then finally, resilient infrastructure that offers security and safety even as we get assaulted by threats from a biological source, from the cyber world, and even from a physical world. And incredibly, this project REACT actually addresses all of these. If I look at it from my perspective, it's about shelter that can enable a resilient infrastructure. It can adapt to surroundings. It can harness and store energy and use nanoparticles embedded in polymers, all designed using sophisticated techniques in data science and computation. So there it is, all 5 themes coming together in a project which I think is clearly a hallmark of at least my first year as dean. I just took over 5 months ago, so this is great. Another anchor in our strategic plan is really our response to what I see as 5 overarching trends in the world today, the mega trends. The first is social change. The second is climate change. The third is economic change, the shift in power. The third is urbanization, whether you look at the US or you look at Central Africa. And the fifth is about technology. It's about the changing landscape in technology. But what underlies all these 5 trends is really globalization. Anything that happens here today can impact the rest of the world. When climate change happens, it doesn't happen just in Alaska. If the folks in Giant and Grenoble come up with a great invention, it's going to change the world. There were terrorist attacks in Paris, and that affects us right here in Philadelphia. So all of these things actually have widespread impact, and this is the underlying trend, I think, today, if you look at those 5 mega trends. And as we think about how to think about globalization in the Penn Engineering context, about Penn Engineering Global, this is it. This is a great way for us to start. A world-class partnership with top institutions both here and in France. This is the ideal project for us. I want to remind those of you who are not here that Penn was founded by Benjamin Franklin. In fact, we like to call him America's first engineer. But something that many of us might not remember is actually also America's first diplomat. And even more striking is the fact that he was probably America's first ambassador to France. Going back to 1776 to 1778, he's the one who marshaled French support for the US. This was early, the first 2 years of independence. So it's only natural when we kick off our efforts to think about global partnerships that we start with France. And I had to bring this in because I found out once I took this job that one of the rules when you speak to an audience, if you represent Penn, you have to mention Benjamin Franklin's name at least once. Well, I mentioned it 4 times, so I think I'm ahead of the curve and I want to stop. So just in conclusion, I think the REACT project is destined for success. And here's 4 reasons why I think it's the case. First, obviously, it addresses really important aspects of both research and education. Second, the strong partners, and I had no idea about the extent of this partnership until I came to this meeting today. So clearly, it's going to have an impact. And this leads me to the third aspect, the focus on education and training in all the right areas, the attempt to build human capital. This is something the world needs. Again, it's destined for success. And then finally, I know all of you are accomplished in your fields, and all of you have a lot of achievements to your credit. Otherwise, you would not be here. But I'm also biased. As the dean, one of the first people I appointed to an associate dean's position is Russ Compasto, and I'm a big fan of the Russ Compasto Club. He has a distinguished record of accomplishments. I think you know this, but what you might not know is he's also an excellent teacher, an excellent mentor, and again, for a partnership of the scope of PIRE, this is very important. So that's the fourth reason why I think this project is destined for success. So once again, I want to congratulate you for securing the resources for this collaboration. I'm sure I'm going to be hearing about and seeing great things from this project. I hope you have a terrific meeting, and good luck. Thank you.